Hi everyone, welcome to MathSpellBook. I'm your host Peter, and we are going to engage with some logic as well as some set theory. So just for all those that are watching on YouTube, welcome. For all those that are watching on Twitch, also welcome. Let me just make adjustments here. I just want to shrink the chat a little bit so it doesn't become too cumbersome for my writing when I'm making notes. Let me see here. I think everything looks good. I just want to double check to make sure that we're streaming on YouTube as well, because you know how it is. Streamers always face like technical difficulties when things don't work out. So just give me a quick second. Okay, it looks like both streams are up. Let's see here. Okay, we got the short stream up, and we have the full screen up. Cool. Alright. I suppose we can begin now. So, basically the reason why I'm engaging with logic and sets is one of my math friends from Discord, like he does his own YouTube channel as well, and I kind of got inspiration from watching one of his videos actually. So let me see if I can pull him up for you guys here. I'm gonna put his stuff. Let me just pull up his channel. So therefore I'll put it on Twitch so you guys can access that if you would like to access that for yourselves. Let me see. I can probably put it on the YouTube as well. So let me just. I can put put it in the description for both of you, for both the short stream and the full live stream. So, so my friend from Discord, he's known as jetbundle, and he basically put out some awesome content that will allow you to be able to access his knowledge on like starting physics from a mathematical perspective, in addition to like building the groundwork in mathematics that'll allow you to build up the laws of physics. So I will put the link of his YouTube channel in the description for both platforms, so you guys can actually have access to it, because I really think that his content is really good. In addition, let's see, let's edit this. Okay, we already edited that, so let's edit. And then we will get into all the other good stuff. Alright, so if you guys want to catch jetbundle's stuff, I put a link to his YouTube channel in the description down below, and for Twitch I put his link in Twitch. So if you want to check out his stuff, you can check it out. My recommendation is just check out his latest video. It's called Climb the Mount Everest of Math and Physics. So that's what inspired the stream. So enough of me yammering. Let's get to this. So I don't know how to go about this. So basically we have one of the books that he recommended to me, and I thought I would just read through and just like basically get through, like, I'm just gonna like, I won't say skim, but I will focus on like reading stuff, and I will write notes when it's necessary. So if you guys need to study or catch up on some stuff that you guys are working on, you're more than happy just to like let me play in the background while you work on your own awesome adventures, or awesome projects I should say. Alright, so let's see, because right now we're dealing with logic. Oh. Make sure that, okay, that's 100%. Okay. Because the thing with me is that whenever I write notes, I write too many notes, and it's usually just copying straight from the book, and I don't want to do that. Because I'm a bit familiar with logic a little bit, so I think I can just jump into some problems here. Here we go. Analyze the logical form of the following 7 English statements. In other words, write the statements symbolically and thereby reveal any hidden logical connectives. Okay, so for 1 we have Emily writes poetry. James doesn't write poetry. Okay, so the main thing is that it involves them writing poetry, but I think symbolically we can write this as Emily as an E. Emily writes poetry, that's an E. And then we can put the symbol for Anne here, and then we can put not, and then J for James. So if James does write poetry, we can just write James does not write poetry. And I think that's how we can write it symbolically. Okay, so now we have either Emily writes poetry doesn't, or James writes poetry. Oops. Don't like it when I write too messy. I know I have messy handwriting, but I don't like it when I write too messy. Because I'm presenting to you guys, so. Okay. Either Emily writes poetry and James doesn't, or James writes poetry and Emily doesn't. Okay, so I think this either is signifying a big or here, so I think what we have to do is that Emily and James does not write poetry, so that's one parentheses, and then James writes poetry but Emily doesn't. So if this is an or, we can just write it like this, and then James writes poetry, so we'll do that, and then and. So the and here, and then not E. So I believe that's how we can write it in a logical way. Like, it's kind of funny that how, like, this is like the building blocks of how to build math, and all we're just doing is just writing words. It's like, this is not the math you learn in school, huh? Okay, Dan and Mary are both correct. Okay, so I'm guessing we can just write D for Dan, and that also signifies that Dan is correct, and then Mary is correct, so that will represent an M, and then since we have an and here, and they're both correct, so we can just write the little triangle there. There we go. Okay. So far, this is getting pretty simple. If you guys need to ask me what the symbols represent for like and or something, like I'm more than happy to cover that, because that's not too hard to go over. It's just symbols mainly. They're just fun to write. Very good shorthand. Are both not correct. Now, I think there are two ways we can do it, but usually, like, since they're not correct, like, it's okay if you can write it like this. However, when we think of math, right, like when you think of like numbers, like if you have a factor and you can factor out something, like for example, if you have like 2n plus 4, you can factor out the 2, and then you're left with n. You can do it like that. The same holds for like these type of things. So since we have a not in front of both of them, we can basically do it like this, which is similar to basically saying this. But I think I'm getting ahead of ourselves. But I think we can structure it that way, because I think like the rules of arithmetic, or at least I guess like with logic itself, we kind of have a sort of like a building block of how it should work. Because when you think about it, it's like Dan is not correct and Mary's not correct, but in general, that's kind of equivalent to basically saying Dan and Mary are correct, but then there's a not in front of it, so they're not correct. So when you think about it like logically, it kind of makes sense when you think about both of them separately. Now, of course, with proof writing, you have to actually prove that this is true, and I think we will get into that like maybe a little bit later in the chapter. This is like based on what I know. I'm not like I still have to like learn the basics of these things. So it may sound like I know what I'm doing, but at the same time, I feel as if like I still have a long ways to go before I fully understand what logic truly represents within mathematics. But I'm just basically explaining it the way I understand it. But if you guys don't understand based on my explanations, please ask questions in the chat. Because maybe there's like a blind spot that I'm not aware of. And sometimes if you guys make me aware of my blind spots, I'll be like, oh yeah, right, why does it work that way? And that gets me thinking about the topic more and trying to get into the technicals of how it works. So that's something I would like for you guys to keep in mind. And if you guys know more than me, you're more than happy to share your knowledge. But of course, if I'm working on a problem, just basically like hold off on like trying to basically like get my brain moving, because my brain sometimes wants to solve it myself, and if I really need help, I'll probably wait 20 minutes before I actually start asking for help. Neither Dan is correct nor Mary is correct. Okay, so I think this is just basically like English grammar, but at the same time like it's just that the English language, like the way we write like neither or nor is like this. But in actuality, if we say that Dan is not correct or Mary is not correct, I think it's practically the same thing. It's just it has an or in it. So usually when we say Dan is correct, we'll represent that as D, and well, this is an or, so or Mary is correct, right? But it says neither nor, so we can write that as like this. But going back to what we said before, that is similar to writing it like this. And I think we have some solutions here, so we're not going to look at them until we get them all done. Oh, oops, I skipped one. So this one is 6. Now we'll go into 5 here. So Dan and Mary are not both correct. Okay, so now I'm going to reanalyze this one, because it would seem that either they're both the same the way I've written it here, or they look different in structure. Now, so it says Dan and Mary are not both correct, right? So it's an and statement. So if we take Dan and Mary are correct, right? So it says not both correct, right? So if they're not both correct, then we have like so now I think what we have to do is like break this sentence down, because it says not both correct and it's an and statement. So if that's the case, because some part of me is thinking that it could be an or statement, because like if we have Dan is correct or Mary is correct, if Mary is not correct, then the statement is still true because Dan is correct. If Dan is not correct, then Mary is. So technically you can write this as an or statement. I mean, that would make logical sense. And this is getting my brain moving because I'm probably overthinking it, but if that's the case, wouldn't that make it equivalent to basically saying that it's not Dan and Mary are correct? Because it's are not both correct. So one of them has to be correct, but not both of them. Because then we would have one scenario where it's like Dan is not correct and Mary is correct, or we'll have Dan is correct but not Mary is correct. So we have these two scenarios here, and both have to be true in order for that to happen. When I think about this one and number 6, I feel as if like neither. So if you write it like this, then that means we can also make this equivalent to because it's kind of like saying it's similar to this. Like the way the structure is. Like when I think about it like deeply. Because it's like not Dan is not correct or Mary is not correct. But then when you actually show that they're both not correct, you can actually put it like this. So, if that's the case, so Dan and Mary are not both correct, meaning, I mean, we can write it as an and statement, which means we have to write it like because the way I think of it is that like this, because it says like Dan and Mary are correct, but we have it so that isn't it's not that they're both correct. So meaning that with this, that means that will be not Dan is not correct and Mary is not correct. So the logical structure, the way I'm thinking of it, is that it would be like Dan not correct and Mary is not correct there. Now, I feel like that's also equivalent to something where it's like this is true and this is true. That means that this statement is true, right? So I know we haven't gotten to truth tables yet, but I feel as if like thinking about this now is gonna like actually help me kind of develop a deeper essence of what it means to be logically coherent. So that's basically why I'm kind of like going around and around with it. But of course I may be thinking too much about it. Because I'm trying to see how this is like equivalent to like an or statement. but I'm trying to make sure that it's rock solid. That's why I'm trying, and I'm not writing anything. But I'll just square this here. Okay, oops, didn't use my pen there. Either Dan and Mary are both correct, or neither, oops, or neither of them is correct. Okay, so this either is going to be important. So it's like Dan and Mary are both correct, which means we can write this. Dan and Mary are correct in parentheses, and then or neither of them are correct. So, which I think is similar to like this. So not let's see. Analyze the logical form. In other words, write each statement symbolically and thereby reveal the hidden logical connective. Okay, so now I'm gonna look at what they expect us to find here, because I know they expect us to know the symbols. And they also gave us the implied symbol. Logical connectives, okay, so I think this one's fine. Emily writes poetry and James doesn't write poetry. I think this structure is fine. Emily writes poetry and James doesn't, or yeah, this either I don't think is gonna mean that much. It just basically is part of the English language to put it in there. But technically when you write it out in this form, you kind of don't worry about that, because you know it's going with this or here. Dan and Mary both are correct, which is, yeah, so we can write it like that. Dan and Mary are both not correct, so I think, like, getting back to that, I think we can write it like this to make it mean, I think it makes it better to understand. Let's erase that. Put that in there. Are both not correct. Okay. Now we can go. Dan and Mary are not both correct. Did I write a problem twice? I think I wrote a problem twice. Both not correct, and I think 5 is are not both correct. Okay, so for this one, I mean, when we think about it, like, just because we don't have the logical operations yet, so I think the way to write it is just basically write it like this. don't want to make it too complicated because like in my, I guess like the way my brain is like kind of interpreting it, because we know about and or, like if it's like if they're not both correct, then like I'm thinking that maybe you can write this as an or statement, but I don't want to make it too overly strenuous. Okay, neither Dan is correct nor Mary is correct. So technically the way I think about this, because we haven't done anything with like, you know, like associative property or connect or commutative like type of stuff, because we're just building up the logic here. So we can basically say Dan is not correct, and then we can put an or here, or Mary is not correct. We can write it that way just to make it simple. And here, neither Dan and Mary are correct, or neither of them are correct. Okay, so they have solutions for these, so let's see if we got it right. Yep, we got that one right. Number 2. Yep, we got that one right. Number 3. Yeah, we got that one right. Number 4. Mary's not correct. So they wrote it this way. And let's see, number 5, how they wrote it. Not both correct. Okay, so the way they wrote it for this is that we did the opposite. We wrote it this way. Now, let's see. In this sentence, the expression not both means that Dan is not correct and Mary is not correct. Let D and M be propositions used in the solution of item 3, which is okay right here. We conclude the logical sentence of that is okay. So yeah, because I know the logic also is kind of like a very stringent thing. So this one is both not correct. So are not both correct. Okay, so I think like the way we read it was kind of like off. So I kind of had a feeling we were gonna get tricked by that, but that's fine. That's a part of learning. So this is this, and this is the opposite. So I think we can go back and basically figure out why we got that wrong. So Mary is not, okay, not both correct. So this means they're both correct, but this adds a not here. So Mary and Don are both not correct. Okay, so I think that's the thing that I think that was the thing that I screwed up on when reading this, because it says not correct. So basically both, so when it comes to scenarios like that, we have to, so we can check this one. So it's neither Dan is correct nor, so I think 6 follows that same structure. See, yeah, they made it and here, because I think you're supposed to like conclude that it's like since they're both not correct, you can make it an and statement here. And what was 7? Either Dan and Mary are both correct, or neither of them are correct. they wrote it like this. Now, I feel as if like there's like a lot of ways to make it work, though. I don't know if we got them wrong or we wrote it in a way that's, I guess, like different from the book. That's the one thing that I'm kind of wondering about. If anyone in the chat knows more about logic than me, please let me know, because I don't want to assume things, because I feel as if this is almost like equivalent to this but we haven't learned anything about associative property or commutative property, so I don't want to assume things. Let me see, because this one is similar to this. Both are not correct, neither. I mean, when you think about it, they can be equivalent. But I don't want to assume too much. Okay, so now we're getting into truth tables. Oh wait, what do we got here? Example 2. Analyze the logical forms of the following mathematical statements. Using only the mathematical relations less than and equal. Look out for any possible hidden connective logical connectives. Okay. Alright, example 2. We have x is less than or equal to 4. And I mean, that's practically a statement on its own, but I think there's 2 of them in there, so we would have to write, let's make p equivalent to, or like means x is less than 4, and then we can make q x is equal to 4. I mean, that sounds simple enough, right? Because it means 2 things. So if that's the case, then that means we have p and q, logically, because it's supposed to mean both things. And then for number 2, we have square root of 3 is not equal to 4. Okay, so I think this logical thing is like basically p would have to be is less than 4, right? But then we can just put the not symbol there, make it like that. Okay, so now we have 1 is less than or equal to x, and okay, so I think we're gonna have multiple statements here. I think we're gonna have 2 statements on both sides. So then we're gonna have 1 is less than x, and then for q we'll have 1 is equal to x, and then for we'll say r is x is less than 4, and then s will have x is equal to 4. And so these will be and statements, but then if that's the case, then I think we're going to have an or statement in between them. Because it says x is in between these numbers. So what we have is that we can have p and q, or r and, oh no, wait. So the thing of it is that I'm kind of goofing up, because when I think about the way this works is that it's a kind of an or statement when you think about it, because it can be either equal to 4 or, wait. Now I'm actually like rethinking about how this works. But I think the or statement works better because like they could be both correct, or it could be one of them are correct, but it's still true in that statement. So I think an or statement is probably better. Which means I think this is an and statement right here. Okay, and then or S. Now I want to make sure that this is logically coherent. Oops, not number 2, number 3. So if this is true and this is true, then they're both true. But then if one of them is false, then the other one has to be false. So I think it's an or. It could be an or, actually. Because usually an or is a better way to like help solidify that, I think. Oh, it is an and statement, like the way it looks here. Okay. I was right the first time. I think it's because like the building blocks, because like if it's an or, like basically like one of them is true, but then they can both be true, and then like when they're both true here, so yeah, so we got this one is an or statement and this one is yeah, so we wrote it in the same way. So the only thing is that when we start adding more stuff, or an and kind of get blurred out like a little bit, like the unification of them both. Well, I wouldn't say unification. I would say like building the logic of it. Like when you build the logic, because like with this, I usually assume that like x is like either in between these numbers, but at the same time, if x is equal to 4 and x is equal to 1, then we have a little bit of a contradiction here. But then like maybe if I break it down, it will make sense. So let's say if 1 is less than x, then it's not equal to 1, right? So that means it's false and true. That makes this true. And then when we have that x is less than 4, that's true. But then this is not true. Then this is both true, and they're like true and true is equal true. However, if these two are false, then this is false. And if this is false, this is false, then we have false, and that means it's false. But if we have this is true and this is false, then that means that ends up being false because it's an and statement. Okay. So if this is true and this is true, then that means that these both are true and that's true, which kind of makes it a little bit weird. Because I'm thinking like if you have like Q and S, like if you have both of these are true, even though kind of technically they shouldn't be, and these are false, like if you have P and R as false, then you both basically have that these both are true. But then again, I'm probably thinking too much in the numbers instead of the statements, because this is mainly statements, this is not really numbers involved. I still have a long way to go before I fully understand this stuff, guys. That's mainly why I'm going through all of this. Okay, truth tables. Maybe the truth tables can like help me get a better idea. Because I'm familiar with truth tables, it's just that they're very cumbersome to make. Especially when it comes to like more complicated truth tables. Hey, Aunt Stunky. What's the best part of your day so far, my friend? Yeah, I'm actually trying to do like a, I wouldn't say a challenge or anything. Like one of my Discord friends who also makes math content on YouTube. His name is jetbundle. I will put his link in the chat. Do I have his link anymore? I probably don't. Let me just copy and paste that for you. Yeah, he basically, like, his channel is dedicated to basically basically helping people learn physics through a mathematical lens. And like he put out his latest video, talks about how you can learn logic and set theory within 2 months. So I'm actually trying to see how I can do that, because I'm just doing chapter 1 of this logics book, and I also have a set theory book that's like right here, now actually, and Stunky, since you're here, let's see, oh yeah, legit. Actually, weird question. Not weird at all, I'm just insecure. Sure, what's the question? I mean, I'm insecure about my knowledge in math thus far, because whenever I talk to you guys on Discord and I know you know more knowledge than me, I feel as if, wow, I am so behind. Stream together? I mean, sure, but I don't know how I would contribute to your stream. Like, I feel like I'm not as experienced as you, but I would love to stream together with you. Yeah, absolutely. I don't mind that. Like, I am humbled that you ask, actually. I guess accept. I didn't think you meant right now. Like, are you already streaming already? I guess. Or you just want to just have us work together, I guess. Like on our streams. And actually, I will give you a shout out, and Stunky, actually. I will give you a shout out on Twitch. If you guys are not, if you guys don't know who Stunky is another math streamer out there. Be sure to check out his content. Straight up awesome math streamer. Knows more than me, so if you have any math questions, you know, check out his stuff. Actually, what are you working on in Stunky? Probably should like probably put your stream on, actually. Because I actually have 2 Twitch accounts, so I actually have to log out of my other one. Accept. Here we go. Okay, maybe you can join the link now. Okay. Let's see here. This is the first time I'm actually doing like I guess a collab like this. So bear with me. Oh. Hey, Academy. Welcome Raiders, welcome. I'm Peter, aka MathSpellBook. Welcome to the stream. How was your stream, Academy? I will give you a shout out to actually Academy of Useless Ideas, because I know you're an awesome math streamer as well. Okay, hopefully I spelled everything correctly. Maybe I should make the chat a little bit bigger, because I'm streaming on both YouTube Live, YouTube Shorts, and Twitch. So, okay. Let's see. Oops. Let me try to refresh. Let me see here. Yeah, for some reason it's failing to load the stream together. I don't know why that's happening, and Stunky. My apologies. Something about that. Maybe it's because I have a YouTube Shorts and a full screen up, because I multi-stream from YouTube and YouTube Shorts and Twitch. It could be that, because it's probably not sure. Yeah, because I can't rejoin the call. This is what happens with streaming, guys. There's always technical difficulties with something. So I think we can share chats. I mean, I have your stream up, so like whatever you're doing, I'll be like observing. I mean, like, if you want us to like chat while we're on while we're streaming together, like, you know, just like have a like, you know, like chat while we work, I don't mind like engaging with you on Discord, if that is okay. And Stunky. But actually, Academy, like, how was your stream actually? Yeah, we're running into some little bit mishaps. This was just like a sudden collab, and then basically just a raid, which I'm grateful for, guys. Thank you so much for the raid, so much. Yeah, but we're going through some technical mishaps. I don't know why that's happening. Because I think we're sharing chats together. It's just that we are not like linked. And I think it's because of my end. Because I'm like multi-streaming a lot. Okay, so... And if you like math or physics and you want like a little math or physics streamer to like keep you busy doing your own projects, whether it be art or STEM, you know, drop me a follow. Much always appreciated. That way we can get to our projects together done. Yeah, can you invite me into Discord VC? Yeah, sure. Let me see here. guess I'll go into my stream VC. Let me see here. Let me see here. I'm about to invite you, and Stunky. Just give me a brief moment. And Stunky, there you go. I'll give you an invite to this chat. Let me see here. If you don't receive the invite, and Stunky, you can join any of the voice chats and I'll just drag you in. I got invited, but lock channel. Okay, yeah, you can like join through like join one of the voice chats, and I'll just like drag you into the stream VC. Like, bear with us, guys. Bear with us. I know we're like doing a lot of like technical stuff in the back end, but we will get back to the maths soon. Do not worry. Do not worry. Hey Sasha, how's it going? What's the best part of your day so far? Okay. There we go.
Brandon here, and then you're probably there. Excellent.
Hey, and Stunky. How's it going?
Brilliant. We're so good at this.
Oh my god. Nah, yeah. Sorry about that, guys, but we are here. Yeah, I don't know what happened with the link up. Like, something went up with it. But
yeah, probably.
Yeah.
Probably just a little tricky.
So what are you doing on your stream?
My stream's seeing me. So okay, very very briefly, just the plan for today was I've got 22 pages on my my virtual resolutions paper. Mm-hmm. I printed them out. I did the hand editing for the first 12 pages, so I got 10 more to go. But it's been a whole weekend since then. I'm assuming my collaborator has done stuff, so I got to do like version comparison. Anyway, like I said, I'm just vibing. Like, it's just, you know, this is just like kind of administrative task that's gonna take a while. So I was like, is anybody else streaming? Because I knew that I was probably catching the end of.
You wanted like a little work company?
I mean, honestly, no. This was totally spur of the moment, because I saw that Zach was going, but he's. Like, I was like, I need to check if I'm overlaying with Zach, and I am, as it turns out.
Yeah.
But then I was like, Uncle is live, and you've definitely been a little bit less active recently, obviously for good reasons. But like, so yeah, I was just like, I kind of would rather like watch you stream. So, well, maybe we can just make this work.
Yeah, we'll do it. I am humbled that you asked me, and I'm like, oh wow, because like usually like with collabs, I'm like, oh my gosh, you guys are like so far ahead of me when it comes to math content. I'm like, sure, why not? Like, I'll probably learn something. But like, yeah, like, hey everybody in the chats, like we're sharing chats, so yeah, so I guess like I'll look on your stream and you look on mine, so yeah, I guess it works out either way.
And as Kaylor mentioned, I don't know if you got a chance to see Slim stream at all, but Kaylor was going in and talking to Slim in their voice chat about complex geometry is.
Oh, I'm nowhere near that level. I'm like, now I'm just covering the basics of logic right now. Like the questions they can ask to each other, I'm gonna be like, yo, like, I'm loving not knowing everything, but at the same time, I'm like, wow, you guys are so far ahead of me when it comes to knowledge.
Let's put that in theater mode. Anyway, so what are you up to? Sorry, let me
I'm trying to figure out more about just basic logic right now, because, like, I did some example problems. I think it's basically, like, structure of statements. So right now, I think I got tricked on, like, certain things. So one example I think I had was, like, oh, here we go. Like, number 4, like, Dan and Mary are both correct. So we have to, like, write it in a way that's, like, logically coherent.
Okay.
So yeah, so I think, like, with number 4 and number 5, I mixed them up. I wrote them in the opposite way. So it's like, I changed them, like, after I realized it, but I didn't realize it until later. And then I think I'm still confused when it came to the last one, which is, like, either Dan and Mary are both correct or neither of them is correct. Because I think I wrote an and instead of an or in the middle here. So...
Oh, I see.
Yeah, so I think figuring that out was fine, but I think when it came to this, I got a little confused because it's like there's 2 or statements, but they have an and statement, like, in the middle. Like an and connective here. So I was trying to think... I'm trying to think of the scenarios where it's like, what happens if it's like Q is true and S is true, but these 2 are false, but if they're or statements, then that means they're both true. And then if they're both true, then true and true is true. So that's when I was a little confused, because I'm like, wait, is that how inequalities work? If that's the case? Because, like, yeah, because they show you the solution here, and I'm like, wait, what? Like, I'm not sure if, like, because I'm trying to find the logic behind it, and I'm like, why is it that if, because X cannot be both, like, 1 and 4 at the same time, right? So it's like, you know, I just find that kind of weird. Unless I'm, like, not thinking of it deep enough. Oh, and I love the horns, by the way. Like, I realized you had horns on your head.
Thank you very much. Yes. Long story. We'll save it for when we're winding down. Yeah, no, I think you're thinking about it right. Like, you're right because of what Q and S actually are.
Yeah.
Then there's this sort of, like, internal structure to, like, beyond just, like, the logical structure that you're writing down. There's sort of these internal structures to the statements, so that it's not possible that Q and S are both true simultaneously. But, like, the logic doesn't know that, and it doesn't need to.
Okay, so, like, the thing that I'm wondering is that, because let's say the scenario, let's say, like, Q and S are both true, and P and R are not true. They're false, right? Based on the way that logic, I guess, is structured, like, that would mean, like, if P is false or Q is true, right? Then, since they're, like, I guess both technically, you can make it true because it's basically a false and true type of statement in an or statement. That would make it true, correct?
Yeah.
And if you have the same scenario for the other side, for R and S, then you basically have 2 true statements in between an and connective, which means that it is true, right? So what does that have to say for the, I guess, the relationship we have here? Because because X cannot be equal to 1 and equal to 4 at the same time.
Right.
I think that's the thing that's kind of, like, making me wonder, why is that the case? If it's just based, because I know we're not thinking about numbers yet, so I know it's based on, like, logical structures. So am I just thinking too much in the numbers, or is it, like, it's mainly just the buildup of how the logic is constructed for this type of mathematical system?
Yeah, I think that the latter is the way that we should be, like, interpreting this. The other thing that I would say is that it's almost like when you're like, oh, well, X can't be 1 and 4, so, like, I don't understand, like, what the logic is saying. You're sort of reading it backwards. When you're making a statement like that, you're, like, looking at all the ways that the logic could be true, and you're, like, trying to see if there's an interpretation in terms of the X, but that's not the direction that makes sense to go.
Okay.
Like, the logic is just what it is, right? I can put in any 4 statements here, and that's, that's going to be like maybe not a true thing that's on the page, but it will be, a valid, well-formed.
Oh, so basically it's like the flow of logic mainly. It's like how logic is like structured, and basically it's like, I guess it's in a way it's kind of like telling you how a logical argument will lead to a conclusion, but that conclusion is basically based on, I guess, like how the structure is made. Is that making any sense?
I think so. I'm willing to go with yes and massage it later.
Because I feel like it's more about the importance of the structure. That's what I'm trying to say, mainly.
Yeah, for sure.
Okay, so it's not really about the conclusion. It's basically how the logic is structured, and if you can see that structure, then basically that's when the logic is working.
Yeah.
Okay, I see. That makes sense. Because I thought the logic is supposed to lead to conclusions, but I guess that's the wrong assumption to make. I think basically, yeah, it's like you said, it's mainly the structure of what the logic is.
Right, at this point.
And guys, if you're just joining the streams for the first time, be sure to give Stunky a follow.
Be sure to give MathSpellBook a follow.
Thank you. So what are you working on your end?
Am I working? So I'm editing a paper.
You're editing a paper?
Yeah.
Is it like a thesis, or is it like more stuff for like a bigger paper or something?
Yeah, it's just a research paper. We started this project 2.5 years ago, and it was like neither of us had it as our top priority, so we've just been dragging it out.
Oh, okay. But that's cool though. At least you're writing papers. Like for me, like I wouldn't even know how to start if I had to write like an actual academic paper.
I'm sure you could manage it. It's not that hard. You just have to.
I don't I remember
everything else, you see examples and then you do it.
Yeah, I remember I like tried to teach myself what is it, LaTeX, or I don't know if you guys pronounce it LaTeX or LaTeX.
Usually LaTeX, yeah.
LaTeX, right? Yeah, so like I tried learning a little bit of it, but then like afterwards I was like, yeah, like I'm not carrying on with it. I kind of got bored afterwards. I mean, it's cool though to write mathematical symbols and create papers, but at the same time I'm like, I didn't carry on with it. I probably should have though. Let's see here. How much more do I have to do? Okay, tautologies and contradictions. Dual monkey subspecies. Duality monkeys. You guys are funny. Theory of everything monkeys. I mean, I am into like the theory of everything. Uncertainty monkeys. So I basically have Unstunky's stream like up, so like if he ever needs to chat, if he needs to chat with me again, like basically like just letting him know.
I see. Yeah, yeah.
Yeah, what's up?
Oh, and you're here. Okay, sorry. I'm like, I still have a lot to learn about how audio works.
Oh, okay, okay. No, I just like cause you muted yourself, and I was like, oh, okay, maybe you want to talk with your chat and like all that stuff. So I just let you do your own thing.
Fair, yeah.
Yeah. So,
yeah, I was mostly catching up with chat.
Yeah. It's fine. Yeah, I'm also keeping an eye on chat, so like in case they ask you anything, I would relay it to you. Because I mean, like, since you're doing research, what do you specialize in, like in math?
Oh yeah, I mean, I guess I could maybe like be polite and actually like pull up the thing that I'm doing, so that it's not literally just you on stream. That sounds like a phone call.
Yeah. Like we still have
anyway.
We still have a landline, and like we still
I won't
get,
draw
like,
any more attention to it.
Yeah.
Oh, we didn't change the title. Oh, sorry, this is the old version, so the title is not changed yet. But so it sort of lives in this realm of commutative algebra. That's the short answer to the question. Mm-hmm. There's a new piece of technology that was developed when I was in grad school, so like less than 10 years ago.
Yeah.
About called a virtual resolution, which is trying to make so there's already something called a free resolution, and this is an algebraic object that tells you something about geometry.
Yeah.
People want to think about more interesting geometries, and you can still create these algebraic objects, but somehow they have too much information. There's just a bunch of like crap that's hanging around. So the virtual resolution is trying to modify the definition of a free resolution to allow you to get rid of the crap.
Okay.
So that it really only tells you about the geometry.
Okay. So basically you're just trying to construct something that gets rid of like the useless data so that you can only get the useful data out of it.
Yeah, exactly.
Okay. I see. Yeah, because I was actually, like, I remember, like, I think a while back I was looking at what homology is, and
yeah.
I think, like, what I got from, like, one video is that if you think of a point and you think of expanding that point from, like, a line to a triangle to a, dang, I'm blanking on the word.
Yeah, to a simplex. What's the tetrahedron?
Yeah, tetrahedron. Yeah, like you have to think of that as like whole homology. Whilst like a homology is like you try to take the bigger shape and you try to minimize it to a point, like all the way up from those steps. I don't know if I'm summarizing that right.
There's a lot that's confused there, but you have like a lot of the right ideas.
I think it was just like the chart that the video showed, because it showed a point and then you just go from one space to another, and it basically expands into like higher ranks and stuff. So like that's what I got from it. But yeah, like I try to get the general idea and I try to like get the details later. And I think that's because like for me, I can't get a mathematical idea solidified unless I can visualize it in my head or get a better perception of what it is, even if it's like information based. Like let's say if it's like a math technique that teaches you how to get from like say making a problem from like differential equations to like an algebra problem, like stuff like that, I actually have to like think it through a bit.
For sure.
Oh, I will be right back, guys. Give me 1 second.
Legit. All right. I guess during the break, I will do the thing that, like, in principle, I'm supposed to be doing. Do I have a PhD? I do. If you're on my stream, you can scroll down, and you can see there's a couple of things down below. One of them is a story about hats. If you click that link, then that's where my thesis is. Hi, Ida. You still haven't told me how to pronounce your name. I'm still just gonna say complete nonsense. I hope you're doing well. Jonas calls me Dr. Stukes, which I think is appropriate. Shoutouts to commutative semi-fields. Commutative semi-fields. Is a semi-field the thing that Max Plus is? Like tropical geometry or tropical algebra? Because if so, yeah, big shout out. So the thing that in principle I'm actually supposed to be doing is that I have two versions of this paper in the downloads. One of them is the one that is up on screen right now. Let me put that aside for a second.
Back.
So that's that one. Hey, good to have you.
Yep.
I am working on the technical side. One of them is the new up-to-date version.
Okay.
Let's see how those are different.
Let's see here.
Jack test.
Well, that's a lot of a lot of code.
What a question. What? Sure, Jack. I'll go with that. I feel like we're sort of on the same page here. Wow. Very, very little change. That's good to know. Okay.
I guess we considered this like office hours for you.
Hey, jetbundle! Good to see ya.
Hey, jetbundle, you made it. Actually, like I started stream up again because this guy, jetbundle.
Oh yeah?
Yeah, because like he inspired me to like actually try to like learn like actually the ground up of how math works and how it can actually create like physical, like I guess like the mathematical structure of physics. So I thought I would actually give it a try.
Physical, okay.
Yeah. On the bus on. Oh, okay. Yeah, I remember those days, like being on the bus going to class. Oh my gosh.
This is strange. I think I'm gonna take a quick break for a second. I don't think that I have the right copy.
Yeah, go on.
Yeah.
Let's see, world would be better if all people on social media could use it. I mean, like, I'm still getting used to it. Like, I'm still getting used to Logic jetbundle. So, you know, I'm probably one of those people that are not used to Logic, or at least like not used to its more complex structure, I should say. Because actually, like, it's good that you say that because I was actually asking and Stunky about this. So, like, one of the problems in the book you recommended, I was actually wondering, like, if, like, say, like, we have Q here, which is equal to, X is equal to 1, whilst X is equal to 4. I put up like a thought, I guess like a thought to Nstunky, like, what if both of these were true and these were false? Because if they are or statements, right, then false or true, then that means it will be true. And if it's true on both sides, then basically it's true and it's true, which means that the whole statement is true, right? So, like, I had to basically ask Nstunky about, like, how to think about it, and that was, like, a pretty fun learning experience, I think. Because I guess I was thinking about more about the numbers than the actual, like, structure of the logic. Okay, so this is a tautology. Yeah, I don't know how far we will get in yeah, like I probably would have asked you the same thing, jetbundle, about like that, like how I would think about that. Because I think I was trying to think about, like, wait, if they're both true, then that means X can't be 4 and 1, right? But then, like, what Nstunky told me is that I'm probably shouldn't pay attention to that. I should pay attention to the way that the logic is structured. So I was like, oh, okay. Because when I think about it, like, even though it seems logical, that doesn't mean it's true. You know? So, like, that's the way I can conceptualize it in my head, but, you know, that's basically how I think I can probably move on from that. Because I think the reason why math for me is, like, kind of like, it's thrilling, but at the same time it's kind of intimidating, because I feel like there's so much I want to learn from the subject, but at the same time I know that I don't have the background information or the background knowledge on how to access certain branches without realizing, oh wait, I don't know this, or I don't know that, or anything like that. So, yeah. Okay, so we have, make a table here too, actually. The word's propositional is a contradiction if it's always false. Okay, no problem, jetbundle. Thanks for stopping by. Good luck with class.
All right, yeah, I exist again.
Welcome back.
Thanks. Good to be back. Do I exist again? The answer is yes. All right. Legit.
Right.
Okay. Right. Just vibing on the armchair. Actually, what I should make you do is share your stream on Discord, but I'm not gonna do that. I'll just
What's up?
keep watching you. I'll just keep watching you do math on your stream.
Oh no, I can do that. Don't worry, I've done it before on my gaming channel.
Yeah, I'm sure your computer is more than up to the task.
Whoops. That's not the right stream I want. Let me just close that for a second. Stop streaming that.
Although I don't know if this actually improves matters, right? If you're just going to be streaming, if you're just going to be sharing your screen.
If it's like a high quality game or whatnot, I think it would be a little bit of an issue, but I don't think it's going to be that much of a problem.
Okay. Yeah. No, I'm not concerned about the like tech side of things. I'm just thinking about like what's actually getting displayed. But this is fine.
Like, can you see my screen, or is it like still like?
It says you minimized your application, so I can't. But
oh, okay.
In principle, I should be able to when you come back.
Okay. Yeah, because I see that it says stream pause, and I'm like, why is that?
Hello, Phobos. Literally don't worry about this. This is not actually helpful.
Oh, okay.
Thanks, though. I appreciate that.
Yeah, no problem.
Appreciate the willingness.
Yeah. I'm trying to make it so it works out for you.
Yeah.
Okay.
Hope the day has been treating you well, Phobos.
Oh, Phobos. Long time no see.
By the way, turn this music off.
True. This is true.
Alright, let's try to remember what we were doing here.
Hi, Phobos. What's the best part of your day so far, Phobos? Yeah, that's right. Yeah, I'm doing truth tables on my end, and Stunky's like doing some awesome math work on his side, some research.
It's that goddamn paper again.
Oh. Dang. I mean, I guess they just have a lot more studying to do, I guess. Let's see.
And of course, TechWorks is just like, nah, don't feel like it. Which, big mood, but also. Just pump that up to 170. Go. Move this over here. Alright, we're just going to start making these edits.
Oops. I'm gonna write this like this.
I should keep my chat up here.
Okay. Let's see what our original question was.
Yes, so what I'm
Alright, guys, so now we'll work on the question that we have at hand here. So we have to let be this one, and okay, so show that is equivalent. Okay, so what we're paying attention to is this one. So with the truth tables, we see that it's false, 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 and T. And what we got for this one, yep, we got that. Okay, we had to do a little bit of I guess rigorous presentation there, but we got there. So yeah, this actually proves that these two are logically equivalent to each other. So I think that's a win. So, oh, De Morgan's laws. Yeah. How can we forget about those?
Cool. All right, truth table seems to be solid.
Oh, thanks.
Oh, yeah, sorry.
No, it's okay. It's okay. Like, I wasn't sure, like, while we're working, like, if we, like, should be muted while we concentrate, or is it, like, you know, we just keep it on all the time while we work?
Yeah, I'm probably gonna, like, so, like, in the future, I'm probably only gonna mute to, just, like, if I'm commenting on things that, like, don't seem, like, useful.
Oh, okay. That's fair.
But yeah, I did sort of explain what I'm gonna be doing to chat. Just
oh, okay. Okay, gotcha. Like, it feels like we're just in a bunch of cubicles and we're just, like, you know, like, doing our own thing. It's like, and it's like, you want to meet by the water cooler a little later? Hopefully you guys in chat are enjoying our little escapades here.
Oh, oops. This paragraph. Yeah, exactly. Hopefully you gotta squint to see the little font. Example 1.2. Taciturn, thank you so much for the follow. Feel free to let us know who you are, how you found the stream. We always like to know who's hanging out. So what I'm trying to figure out right now is... Oops. Yeah. This figure. I feel like this figure should be here. I'm gonna move it. He can move it back if he doesn't like it. There's a little ghost who's saying that I can't see them right now, which is true.
Yeah.
Feel free
I just saw that.
if you're interested.
Yes. Or you could be a virtual particle.
Backwards in time.
Yeah.
This is your first time chat, and now I'm gonna like gradually fill you in my memories as you work your way back. No, that is the right figure. Okay, put it where it's supposed to be. There it is. I think there's a typo. Yeah.
Get rid of that typo. We don't need those.
Fuck them up.
Yeah.
This is like the only substantial change. Particular. Where's that associated? In particular, this sentence. Only. I told you, Mouse, this is my true form. We're gonna be here for a while. Hope you're not waiting for it to pass. But good to see you again, Mouse. I don't know how well the algebra stream was going for you, but I saw that you had somebody who had popped in, so hope you enjoyed yourself. Ooh, another typo. Where's that M? That M. Where's the tau? Definition for all tau. Let's get rid of this. Going for your second dinner. Rex, is this true? Is Mouse slandering you right now? We don't just repeat claims that we see on the internet, Mouse. Where's that theorem? chunk. Right. Theorem 1.4. Definition. There it is. Oh, this is one of these that has so many line breaks. Prime be a subdivision at good simp. It's protects by that. Good synth, exactly. Trojan, no. Okay, that might not be true. Maybe in grade school I did manage to do this for some kind of like summer reading program. Nowadays, I think in 2025, which is the most that I've read in, gosh, probably since I left college. 2025, I think I got finished with like 10 books. That's probably true. It definitely wasn't more than 15. 10 feels about right.
Yeah, I wasn't a good reader in like elementary school. I started reading when I was like, I think after college.
Oh, all kinds of stuff, Trojan. So the ones that stick out to me from last year were, man, there was a really good book that I didn't finish because it wasn't mine, and I had to give it back to it was my cousin's. I had to give it back to him before I got through, which is like the first one that comes to mind. It was about it was basically like a pop monograph about shame. So it's this woman who does who researches shame, in particular how it intersects with community and gender, and some really interesting ideas there. Hard for me to like pick specific things out, but there's a lot of like I can feel that book like showing up in my thought processes as I'm like navigating my own way through guilt and shame. Got some good fiction reading. The one that sticks out there is I finally read the last book in the Bartimius trilogy, which I read the first two books when I was a child, and but the third one wasn't out yet. So, but I finally managed to pick it back up. Yeah, that wasn't last year. Wasn't Curse of the Immortals. Oh, I read The Alchemist. That's probably the most famous book that I read last year. And there was another book by a Latin author, which is a little bit more like high lit kind of stuff. Definitely like the highest art that I read last year. The Lost Steps. I think The Lost Steps is. I would recommend that one. It's particularly for people who watch my stream, and probably yours as well. It's very. It's about a guy who's like an advertiser in New York, but he studied like music history really seriously, and his old mentor gets in contact with him to basically run a scam on the university to give him like a vacation while he's like going to like allegedly do this uh like find primitive instruments in, oh, I really should know. I think it's Brazil. I'm probably getting the country wrong. Um,
Talk about
it
scandalous.
sounds right. Yeah, the book goes in some very different directions. I will say that is not at all a spoiler.
Hmm.
The this plot, I wouldn't say this plot is dropped, but I would say it becomes significantly less important
Hmm.
uh, as the things start layering on top of each other.
Mm.
Um, Good stuff. The Lost Steps by Alejandro. I'll look it up.
Mm. Yeah, it's funny because I was an English major in college, actually.
Oh, really?
Yeah, I don't know that much about literature actually. I just liked writing.
I mean, fair. Yeah.
And plus, I
Alejo.
didn't have to
Okay,
worry about
that's
exams. I fell in love with math and physics like my last semester, like of actual university before I graduated, and I was like, oh my gosh, dang! If I knew what math and physics was, I probably would have changed my major, and if I didn't have student debt on that.
Sorry, how did that finish up while I was just like yammering about books I've read? Because didn't completely love what I saw in the truth table. But how did that end up going for you?
um, Going over it, yeah, it was very tedious. Like I probably did more steps than I should, but I just wanted to see it all laid out. I felt like I might have missed some things like during the P, Q, and R section. Like I probably missed like one section of like T's and F's. But at the same
Oh,
time,
I see.
I'm like, I mean, at least I connected them. So I feel like if the rows match up, then I think it should prove that these two are not equivalent. Because I think the whole entire problem
Yeah,
was proving that those two are not equivalent. And I think we did what we did.
right. I think so too. Yeah.
Yeah, that's the one thing about math that I think is you have to get used to is the rigorousness of it, and you're like, oh man, I got to do this by hand. You're kidding me? I mean, luckily we have computers, but like I'm not interested in programming either, but I might have to learn how to like at least program something. Maybe.
Yeah, probably.
Maybe.
Seems like a good idea.
Yeah. Unless I can like master like vibe coding or something to make it work.
Yeah. Was trying to figure out a way to bring that up, but
Because I'm actually trying to write a novel
um,
too, and it's basically based on like mathematical ideas mainly. It's like I'm trying to make it like a fantasy one where you can use math to create things around you.
oh, okay. Yeah, I'm curious. I'm curious, like where you would want to take that narratively, because I
Hmm.
sort of feel like when I was like into my like stick figure comic era,
Yeah.
um, this was like a thought that I had, but I never really came up with a story, like, and so I
Uh.
just kind of it sort of drifted off that project. But
Hmm. It's mainly like revolving around the multiverse. So yeah. Um. Like I thought of the story like long ago, but like I haven't been able to construct the mathematical I guess like structuring of it. So I thought I had to
oh,
like
that's
learn.
interesting. Okay.
Yeah, so I thought like maybe I should learn how to build math from scratch. So that's like how I got like very interested in like researching more math and physics. I like researching more than actually like writing the book, but now like I'm actually trying to write at least a page a day. So, because I think
Sure.
because the thing of it is that the characters get involved in fights, and these fights are like similar to like Harry Potter battles, where it's like,
yeah, that feels natural.
Yeah, so like basically like instead of like just magic, they use like thought experiments to basically use their mathematical knowledge to utilize like the setting around them to like fight against their enemies. But I have to like think about how the system works, and like for me to do that, I actually have to know like the conservation of energy and all that other stuff. It's pretty complex.
For sure, for sure.
Read any books on other kinds of logic or ethics? No, I have not. Actually, philosophy is like my low area of expertise. Actually, like I can't consider myself an expert in pretty much anything, to be honest with you. Oh, interesting. Yeah, I'm like checking up chat, like what chat is talking about. It's pretty cool. Feel like learning stats. Yeah, everyone has like different motivations of learning math. Like mine was physics, but like some people want to learn math for like finances. You can do that too, actually. I feel like the branches of like different academic pursuits are merging. So like you have finance merging with math, you have like I think math merging with like philosophy. Like there's like a lot of stuff mainly.
Yeah, a lot of the like what the fuck is going on? Okay.
Is it a problem? You're facing a problem?
Yes. Allegedly, this document is the same as the document that I have printed, but it's literally not. I'm looking at something that's not the same. So, the hell are you talking about? Okay. Anyway, sorry. Yeah, a lot of the hype, like academically, has moved out of interdisciplinary programs. Like this was just like a huge, very very hyped thing in I'd say like the 90s, right? The 90s and early 2000s. But I think the legacy still remains. I think that it did bring together a lot of folks, and people still sort of take seriously these interactions in a way that probably wasn't true 50 years ago.
Oh, hey, Jose. Yeah, Happy New Year to you, too. Thanks for wishing everyone a Happy New Year.
What's up, Jose?
Oh, what else did you guys type? Have you ever tried using critical thinking worksheets to brainstorm solutions? No, but maybe I might consider that actually, because that sounds like a pretty good idea. Good way to start the morning. Because usually for me, like when I get up in the morning, I just like write something in my journal, like just like positive affirmations, and then I get to like now I actually am writing one page of my novel per day, and then I read books mainly. But that might be a good idea actually. I might try to incorporate that, because maybe my critical thinking needs work.
Gamma M. For every monomial.
Yeah, it has been a while, Jose. Yeah, definitely. Yeah.
if for every monomial where L of E divides M, and okay. So if for every monomial where this is true and this is true, we also have this. Yeah, okay. I don't know why he's he seems to be very concerned about this phrasing, but this phrasing is fine. Yeah. Okay. Okay, so this was the old version. This is the new version. I'm happy. Right. We'll leave that one in there. Okay, we're still trying to fix this theorem. I think that's fine. You put the L prime in there, so we're good. All right. Okay, but this should have shown up. Should have shown up. Yeah, I don't understand which documents we're comparing here. No, okay. Okay. Got it. No. Okay. So in this is already the new version. And this is different from the piece of paper that I'm holding in my hand. Which on one hand is fine because it's updated. So in principle, it should have less errors. But I don't know what changed. And I can't figure it out unless I go line by line through this, which I don't want to do.
That'll be fun.
So I think what I need to do is I just need to make the changes that I said I was going to the extent they're still relevant in this version. he probably did not make the changes to section 4 that he was intending. So it doesn't make sense for me to line it at section 4 yet. All right, well, we still got a couple pages. So can you describe to me like what you're doing right now, like rhetorically what you're doing right now? Because it does seem like you're rephrasing these rules in the book into your notes.
Yeah, I'm just basically writing them down because, like, I guess the process of writing lets me, like, I guess, feel like I'm solidifying it in my head, but at the same time, like, I'm gonna reread it, like, probably, like, over and over, just so that I'll be like, okay, these are the things that I have to, I guess, keep in mind. Because usually when I see, like, equations and stuff, I just write them down, because I know they're going to be relevant, like, maybe while I do the problems.
Okay.
So now that I just finished writing this stuff, I'm going to actually look it over again, because whenever I write notes, I always forget that I was focused on writing the notes instead of focusing on the content of the notes, which is not very good.
Yeah, it's classic.
Because right now I am on page 10 and I think I think this whole chapter is 26 pages in total. So I'm not even past 1.1 yet.
But we're close.
Yeah. Logic, clauses, substitutions. Logic clauses. Okay, let's see what the questions are. Only one of the following is a tautology. Which one is the... Okay.
Yeah, Fluffy, this is something that I always have a difficult time with, like, because in principle, it, like, if you're learning this, if you're learning logic, you do have to see this stuff. You can't just skip it. But you wish you could, because it feels like wildly
obtuse.
Yeah, we're just like sort of symbol pushing, right?
Yeah. Let's see. We have an and here.
Yeah, I don't know. It's here. There's always like a section on logic at the beginning of Intro to Proofs courses, and I'm just kind of like, yeah, I guess technically you do need to do that, but it feels like you're setting the wrong tone, right?
Do you like it when they start with set theory instead, or you feel like it doesn't really matter for you?
I think set theory is like a decent place to start. I think like my instinct is always to start with like counting stuff, but this is probably like a bad thing to do in general.
Yeah.
I think like I think like some naive set theory and perhaps like in service of basic number theory is like my first pass at like the correct thing to do, according to me. To teach the thought culture around mathematical proofs, it's difficult. There's a reason why we do it this way, and that's because like a way to do it better is tricky, right?
Oh yeah.
Yeah, and so in practice, in the practice of teaching, people just kind of like use what's available because it's really
Yeah.
there's really a lot to think about if you're trying to sort of restructure these early stages.
Yeah. Like,
Definitely think it's possible. Yeah.
yeah. I think like when it comes to like doing mathematical proofs, um, you have to think about like what did I ask, like what questions did I ask like back in like high school or elementary school. It's like the question is like why is it that I have to why is it that two negative numbers equal a positive number? And like usually the teachers could never give a proper response to that because it involved actual mathematical proofs for that.
Right.
And now with Google and the internet, you can look those up. And well, first you have to know what a mathematical proof is first. And when you actually realize, oh, this is not something they pull out of their like out of their you know what's, but this is actually like proven that this is true. And then you end up asking other questions like why does subtraction work? And why does addition work? So I think when you start asking those questions, proofs, like you kind of get a little bit more motivated to learn proofs at that point. The problem is that you realize, oh, there's a lot more details in these things than what you were meant to learn for like just pure arithmetic and like algebra and calculus and stuff.
Yeah, for sure.
Because I looked up like if you type it like give me a proof that proves that negative numbers like multiplying two negative numbers equals a positive number, and you realize that it's a 20-page proof, and you're like, oh, this is the reason why they didn't teach us this.
Differentials for this complex are given by. So this needs to change. And now we lost it, of course. Very good. There it is. Yeah, I'm satisfied with that. We don't need to explain that this has one element of difference because that's implied by this notation. Okay, yeah.
Okay.
But you do need that because otherwise, otherwise, what are you doing? We get a whole page error-free. Mark 2.5, the infamous remark 2.5. I said there's supposed to be a twiddle somewhere. Oh, yeah. Right. All of these twiddle H's, we're gonna subscript them with J's instead. First direction. Am I gonna do that in the problem statement too? maybe I'll just leave it here. Maybe just that one.
At least you would be concerned about that. Based what you typed in the chat, yeah. For me, I wouldn't notice because I would be like, oh yeah, like we because in school I didn't know anything about proofs, so I'd probably be like, okay, if he said it's that, then I probably should just do the homework. That's a sentiment, by the way. I'm
There is
salty
an
though.
actual issue here, which is that this should be. Yeah, this should be something else.
Yeah, that's an interesting point, actually, because like when I think about it, like if you were to teach elementary school students like arithmetic and then teach middle school students like algebra and geometry, and if you were able to teach like I guess high school students pre-calc and calculus, then yeah, like maybe math proofs you can actually introduce to them like while they're in high school, but more likely they probably will think like, what is this? That's not math. It's like, I'm so used to calculating things, why do I have to do this extra writing? And the geometry teacher will be like, you did this in geometry, and I don't even remember proofs in geometry at all. Like I felt like I calculated more than do proofs in geometry.
Yeah, you do something in geometry. Calling it proof is generous.
Yeah. I don't even think teaching proofs is necessary in school though. Yeah, that's true. School is like, unfortunately, school was created to make workers out of everybody. So, like, there's no point in teaching them proofs unless they're doing like computer science. And computer science, I think, like, they will utilize at least proof writing for programming and stuff. I mean, they can use that skill. Doesn't mean they have to. So I think that the tautology, maybe this one.
Girl, this is not true. Why are you writing this? Okay.
Right, yeah. Yeah, I think proofwriting is just a great way to just sketch out the programming and how it works. Because when I started learning proofs, I felt like, oh, like this seems similar to when I was learning C++, plus plus in a way, because it seemed like the logic was just being built up. Because I think when I learned C++, plus plus, it felt like I was learning the logic and structure of the language. And then I was kind of like working my way down to actually creating the functions. Yeah, I know it's not very like very actable, but I feel like the skill itself is like, it's like how mathematicians basically say we're teaching people how to think, literally. Like when you actually use the ability to think in proofs wise, it kind of feels as if like you can utilize that like somewhere, but it's like the same as like how should I say, like you learn something that's completely abstract of something, like say if you're learning how to play sports and then suddenly like you're thrust into physics and then suddenly like, wait, the ball is supposed to follow the path of a parabola, and then you realize that like, oh wait, like I've done this before, then that means like I have to throw it at a 45-degree angle to get the furthest distance. You know, it's like stuff like that, but it's mainly like the knowledge that is very abstract in your head and you don't know how it makes sense, but somehow it helps you make sense of the world or make sense of the subject you're doing. It's more like a muscle mainly, because that's how knowledge is. Knowledge is very, very abstract and it will always pop up when you least expect it, and then you have your eureka moment or whatever it is that you feel like you want to call it. Let's as well as the right notation. Right, yeah. Like knowledge and skill are like, I would say knowledge and experience. Like knowledge and experience are always a must. Like the more experience you have, the more your knowledge seems to expand, but also like the more you learn, the more you want, like you have to also develop the desire to experience what is it that you've learned like firsthand. I think that's why people get into science, because it allows you to touch things and interact with things. Unless you're getting into quantum mechanics, which is you're gonna have to need like an expensive lab for that. You know, like I'm not talking about I'm not talking as if I had experience with that, but like I just imagine it, because like I don't have experience with that whatsoever. Like even doing those like corny experiments in the lab for classic physics, you actually gain like some sort of like intellectual muscle with that, because it helps you with other higher levels of physics, even though they seem kind of mundane and terse. How do I gain the skills to apply it?
Getting close.
That's kind of like a tough one, because like say if it's math, for example, like you end up wondering like how does it interact with like something that I can touch that is tangible, and usually that's when your curiosity has to overwhelm, like I wouldn't say overwhelm, but kind of like overlap what you experience, because then you have to like look up stuff like when do I use logarithms in real life, right? And like you start learning things like, oh, it's used for earthquakes, it's used for like how to set up like volume and sound systems, so that when like manufacturers make like dials for like the volume, that's why the sound sounds like it's like 10 times as loud than when you set it like at volume 2 or volume 4 or something like that. Like I know I'm totally not getting the numbers right, but that's usually how like logarithms play a part. But when it comes to like more complex stuff, like the stuff that Enstonky is like researching, I wouldn't know where to start, to be honest with you. But I would usually start with the fundamentals, like, and if they describe it in a way that makes sense to me and I'm like, okay, then I try to see if I can fiddle with it. Because I have no technical idea of what homology is. But I got like a little bit of a broad stroke by just like looking up stuff, like reading up stuff, and see where I can bring it like and apply it, mainly like in my imagination, mainly, not really like in physics, for sure, but not really in nature.
Highly motivated to learn something. Haven't been able to absorb the information. Yeah. Since I'm sort of coming in and out, I'm not quite sure what the antecedent is here, but like what you said is certainly true, Fluffy.
Mm-hmm.
It's the relationship between like how motivated you are to learn something and how well it sort of comes through is it's not there, it's not no relation.
Yeah.
You don't want to be sort of throw the baby out with the bathwater here, but it's not it's not as simple as you'd like.
Yeah, I mean, like anything that's hard, it's never gonna come easy. But at the same time, like you have you have many ways of interpreting your journey, because some people like to go through the hard knocks journey where it's like, I got to do as many push-ups, or in this case, like I got to do as many math problems or physics problems as I can to exercise these these intellectual muscles in my brain. Or you can be like, no, I like this as a hobby. This is a cool thing, and I just do it from time to time. And then you realize that a problem pops out of nowhere for someone else that you know, and then you're like, oh, you just have to do this. And then they're like, how'd you do that? And it's like, I just saw it. And it's like, and then you get these comments that's like, oh man, like I wouldn't have not seen that. It's like, you know, I just did. That's all. It depends on what path you want to go towards. If you want to be an expert, then yeah, then you just basically try to talk to people that are where you're at, but then they're a little bit ahead of you, and then you basically just learn from them. And then you learn as much as you can, and then you move on to the next step, mainly. Because that's why I like, you know, our streams. Like I like it, and Stunky streams math. I like it that like a lot of my friends on Discord, they stream math, and they know way more than me. So I'm glad that I am like the person that doesn't have a math degree, because it's like I can learn so much from like people that do. Even though I probably won't understand, like probably I would have to say like over like 80% of what it is that they're doing. But it's interesting.
I feel like you need to talk to somebody, and probably this somebody should include Rex, about who your math friends on Discord are, because I am not sure. I'm not sure I know who these people are, which is, it feels like strange to me, because I feel like I know, at least on Twitch, sort of the I was going to say the broad structure, but actually some pretty fine details of the structure of the math streaming community.
Right, right.
But yeah, I mean, like, I did not know JetBundle, and I don't think that the people who you're talking about are sort of the people who I think about. So
I think it's a mix. It's a mix. Like I remember like the communities we interact with, and like JetBundle, I started interacting with his community a lot more, and they love to talk about like complex ideas like a lot, and I engage with it even though I don't understand like a good majority of what they're talking about. But it's mainly like very technical, and I'm like, oh wow, like they talk about things like like it doesn't revolve around like quantum gravity or anything, but it feels as if like they get into the nitty-gritty of like what makes quantum mechanics, or like how can we utilize like math in ways that benefit like things like finance and stuff. It's like very outward thinking, and I'm like, oh, that's really interesting, because I would never have thought of that. It's like playing with math, but at the same time, it's like we know it has a structure to it, because math always has like a very logical structure to it. So it's like, how can we use this logical structure to give us like systems that actually work efficiently?
Yeah. Oops. Gosh, what am I looking for? I keep looking for something. This.
Hopefully, me talking to chat is like not interrupting your work and Stunky.
No. I mean, yeah. Speaking of which, I'm actually going to take a quick break. My stream is allegedly watching ads right now, so
okay.
I'm gonna go to the bathroom, take care of myself, and in case anybody hasn't done this in a while, I encourage you to,
yeah,
all that good stuff.
Yeah.
Are you planning on being around for another like hour or so? I know this is
probably like another half an hour.
Okay, yeah. I was gonna say, this is sort of already longer than I'm used to seeing your streams, so a pleasant surprise, but I don't want to. Yeah, just want to be cautious.
No, that's fine. That's fine.
See y'all soon.
And I'll probably do the same thing that Unstucky's doing, so I will be right back as well. So just give me a quick second, guys. Alright guys, I'm back. Hopefully you guys didn't wait too long. Let's see here. Alright, so might as well get into this last question. And I think I'll try to read some of this book afterwards. Let's see. Using De Morgan's law, write the negation of the statement. Run runs Thursdays and Pete plays poker on Saturday. Express your answer in English. Okay. So. So the negation of here.
All right.
Welcome back.
Yeah. Good news, chat. We did it.
Oh, nice.
Did 11 pages. I thought there was one thing. Oh yeah, there's one sentence that I'm not really sure what I want to do with this. So this bit at the beginning of section 3, when we're like, it feels we like imply that we're going to talk about something, but we should say we're going to talk about something. But then other than this, we now have to make sort of the tricky decision about whether we're going to do anything for section 4 or not. And I'm just not going to do that right now. I'm just gonna put that on hold for a second.
Yeah.
So which is it? Question one. Is it A or
Question
B?
one.
Yeah, yeah. I don't know if chat had any opinions, but
Yeah.
what did you find?
So I think it is B.
Okay.
Because I know that
Why is that?
P or not P is like a tautology,
Yes.
and the thing of it is that when I actually did it for the and statement, we got like two different values, and I'm
Hmm.
like, that's not what a tautology is.
Sure.
So I basically like, if it's an or statement, then I'm like, well, if one of them is false, then that means it will be true regardless
Hmm.
at that point. And like I actually did like the truth table, and I was like, okay, that kind of works. And
Yeah.
I feel as if that's the structure that they were going for. And I think I wrote it here, but I didn't want to look at it. That's why I didn't want to like peek up and I'm like, oh, I'm cheating. I'm like looking at this. Like which one's a contradiction and which one is a tautology. But I mean, like, if I got it wrong, you
Well,
can
it's
tell
not
me.
actually written. It's not written in that list. So you could have peeked.
Yeah, I could have
Um,
peeked, but at the same time, I felt like if I peeked, I probably would have cheated, and I didn't want to cheat myself.
so it's not in the list. Like
Yeah,
you wouldn't have found it.
right. Yeah, I was paranoid for no reason. Like, see, like this is what I mean. When I write notes, I forget. I focus on writing the notes, but I forget what I actually wrote.
Now you can use them.
Yeah.
There is a really useful one up there, which doesn't immediately solve the problem, but
Mm-hmm.
is very useful.
Yeah. Let's see. Yeah, that's tautology. Oh, and it's a contradiction if it's or. Um, but it has to be a contradiction. Yeah, it's just P or contradiction, then side P. Yeah, I mean, like, I think that's correct. It's B.
It is B. Yeah,
It is
that's
B?
correct.
Okay, okay. I was
Yeah.
starting to psych myself out, but I wanted to double check because the thing, like, with me and math, like, when it was, like, computational, I would miss something. Like, whether I would do an arithmetic mistake or I would miss a negative sign, and I would get so mad. Because I was like, I checked it 3 times. How did I miss that?
Yeah.
um, but yeah, number two's problem was pretty interesting, especially when I wrote it down and I was like, oh, that's it. Because I already knew what the statement was, but when I wrote it out in like De Morgan's laws, and I was like, oh, that's interesting.
Yeah. So actually, you wrote the De Morgan's law is correct, but you didn't translate that back into English correctly.
Oh, okay. Mm-hmm.
Peter's going strong. I think Ron's going strong. Peter's going broke. I guess. I guess what do I want? Well, we'll just leave it here. Yeah, and how would you describe that difference between like what you wrote now and what you wrote before?
I think like it's because I think the nor like basically makes it as if it's in the parentheses. Like that's the way I can think of it. Like the negation symbol. It's like when you have the nor, it's like the same as like having neither nor. Like
Right.
that's what I was thinking because it was sort of like it was like I was trying to write this out, but then put an or in there instead of an and. Like
Right.
that's what I think what you meant is that it was not correct like grammatically.
Yeah. Yeah, I agree. That's a good way to describe that.
Mm-hmm. Is that what you meant? Like,
That is what I meant. Yeah.
okay, yeah, because like I figured it was something small like that, yeah. Because like I forget that when it comes to statements, they have to be logically coherent, and I was like, oh wait, hold on, yeah, it's not like literature where you're just like you can write it in any other way. I mean, it could be interpreted that way, but at the same time, it's like like when it, because I think that's where math, computer science kind of merge because it's like because of the logic is kind of so stringent, it's like no, you have to read the sentence like that because if I was a computer and I didn't know what English was, I actually have to interpret it in that way.
Sure.
I mean, if anyone knows more about like language models, like tell me that I'm wrong about something because I know I'm more likely going to be wrong about something with that statement. Because everything I say that seems like it kind of comes from my brain, it's more like an interpretation, I should say. But I need people that know the technicals to explain to me, no, that's not how it is. And I'm like, okay, please explain. I need to learn. Uh, let's see. What else? Negation statement. Okay. Computer program.
Okay. Are we reading chat? Is that what's happening now? Could be. Sure. Okay, well, what could we do instead? The other thing that is worth doing today is I would like to have an abstract for a talk that I can present. So if you were here last stream, you saw we were discussing, I'm hoping to be at the AMS Western Sectional this March. And we're hoping to get ourselves into, I think no, not that one, this section, Community of Algebraic Geometry and Applications. I think like you could make an argument that this is sort of a hypergraph thing, but I wouldn't call it like a recent trend. So I think this would be a hard sell. This section would be a hard sell. But we do have this. So who are these people? Who are you? Zach Tietler. And Stefan Ovidiu. Yanu? Tohan Yanu? Tohan Yanu? absolutely no help at that pronunciation.
Oh, I think I've read about that. EBID A, because I'm reading a book about Warren Buffett's strategy for picking businesses.
Oh, yeah.
I remember reading about that in I think when they were covering about was it income statements. I always love that little dance emoji. It's cute.
It's a good one.
Yeah, it's cute. Okay, I think we covered a lot on logic. I probably should read a little bit on sets. And then we'll probably end stream within like 10 minutes, so that was pretty productive though. Let's see, sets and mapping.
I don't know. I was kind of hoping that you would get to problem 4, but
what is problem
if you only have a
4?
few minutes, then maybe the reading is a better use of time.
Let's see, using propositional logic, supply laws that justify. So. Yeah, why not? Like, we can do 4 because it's the last one on this page.
Yeah.
Okay, propositional logic laws.
The famous algebraist Horn. I'm assuming you're referring to somebody on this list, Kaylor, but no, you're maybe not. Kaylor is on your stream, allegedly. You're referring to me. Oh, okay.
Oh my gosh, Sasha. You did too much algebra. Oh yeah, because Sasha, you're into geometry mainly. It's like
exactly.
If algebraists and geometers like argue, like you said, like go to the category theorist, and they'll settle your argument for you.
Oh no, the category theorists are in the pocket of big algebra. You can't trust them.
That's good to know. See, I did not know that. I guess with physicists, it's like all the string theorists that they have too much. They think that they're all that, and I guess the category theorists are like that way when it comes to math, right?
Yeah, I think there is. The analogy is not unwarranted.
No, Sasha, don't gaslight yourself. Don't do that. Don't do that. The last thing we need is mathematical trauma.
All right, so I'm never gonna win Tytler over Tytler. Probably Tytler. Tytler does too much number theory. He doesn't give a shit about what I'm doing. But Tonyano, quite possible, right? This in particular looks pretty promising.
Oh, just these are the laws. Okay, propositional laws. Supply a law justifying each step. Okay, let's see.
Like, clearly a coding theorist, but...
That's a thing? That's a thing? Coding theorist?
Yeah!
That sounds like... it sounds like something like, yo, do you work on the Matrix or something? Might as well be the architect from the Matrix. Is like, hello, Neo. It's like, who are you? I am the coding theorist. Let's see, P or not Q, and not P or not Q.
Section. This section.
If and only if, not Q or P. Oh, that looks like a union. Why did I write it that way?
I like how in this session, in this meeting that runs for 2 days, so it has a morning session and an afternoon session, and the special session has 4 parts, but we're fully not committing to a schedule. Just, it's like, well, I have a pretty strong guess that the first part is going to be on Saturday morning, and the second part is going to be on Saturday afternoon. But okay. Unscheduled, sure. This is all we get for what this entails. A broad range of topics in commutative algebra. Well, I'm a broad range of topics in commutative algebra.
What does that cover, commutative algebra? Is it like just on like the commutative like law of like arithmetic?
I mean, in principle, but in practice, people mean like polynomials. They mean this the study of multivariable polynomials. Yeah.
Oh, okay. When I think about it, I'm like, when does like algebra not involve polynomials? Let's see. Supply the law that justifies each step. Okay.
Strong guess. Yeah, exactly. The strong hypothesis.
So this one. Did I write this right? Yeah, that's right. Correct.
So what's our current abstract? Could we just submit our current abstract? Should probably be our first guess. And there was a title issue too, right? Proposing the title, Homology in Simplicial Virtual Resolutions. It's definitely a lot better than the current title. But it's like a little too general, right? It's maybe suggests we're talking about some things we're not talking about.
I think this is...
Jay's insight here, I think, is like really useful for this specific task, or for this specific audience, which is that like he wants to call this paper removing homology from simplicial virtual resolutions. But he says we shouldn't call it that because people are already not in the habit of thinking of simplicial virtual resolutions that have homology. So even though in principle people know that you can have it, to say that you're removing it feels a little bit strange, just in the current climate. The way people understand this stuff nowadays. So if I were giving this talk, like I might use that title for the Boca talk, because that is mostly not a group of algebraists. That's mostly a group of combinatorialists. But since I expect that most people in this audience will be algebraists, we don't want to use that title for that reason. I think first of all, I'm going to just replace that. While virtual resolutions may have homology, few examples have been constructed, and even those examples are not well understood. to this problem, we bring an new technique. How about a new technique? Builds on the ideas of simplicial resolutions of monomial ideals. Simplicial resolutions of monomial, yes. We give conditions for a labeled simplicial complex to give rise to a virtual resolution, a class of examples of virtual resolutions with homology, and some techniques for removing homology from simplicial virtual resolutions. This is not a bad abstract, but we're not going to talk about all of those things in 20 minutes. So we want to be a little bit more general in this last sentence. Okay.
Okay, I think I'm almost done with 4, but I think I'm like missing something.
Yeah, I was just checking in on that there.
Actually, I can probably reduce it a little bit. There we go. Unless I'm writing them in the wrong order.
I'm sorry, is that associative and commutative, is that attached to the first line,
Yeah,
or the translation from the first line to the second line?
I think it's attached to the first line. At first I wrote commutative, but I felt like when I look back at associative and commutative, it looks like it's combining both of them.
So I don't see a way to use the associative law here. And the reason why I say this is because associativity requires that we have 3 objects that we're performing the same operation in between each of the 2 of them, right?
Okay, so
this is how associativity of addition works.
So it's just mainly commutative then.
Yeah, it looks like commutative is just being used twice here.
Okay, I guess I psyched myself out with that. Yeah, because I think it's the way I wrote it in the notes. I think it's because like I was looking at this and I wasn't looking at the other side right here. Yeah, but commutative, yeah. I can see commutative though. This one. Wait, I probably should write the truth table for this. Just so that
No, definitely don't do that.
Because I'm like, is that a contradiction or is that a... I feel like it might be a contradiction. Because it's an and statement. Yeah, I think it's a
I see.
I think that's a contradiction. And that's an and statement, right? Oh, that's an or statement, so... Yeah, it's a contradiction. So yeah, it's a contradiction law. Now the one thing is that I'm not, because I know it's not double negation for like the last one.
The last one.
Yeah, because the last one is like just not Q. And
yeah, but that's what you're using contradiction, like to get from the second line to the third line.
Oh, okay, so I have to write the one that's for the second line, right?
Right. Yeah.
Okay.
How did you get from the first line to the second line?
Oh, okay. Let's see, not Q. So we have not P. Okay. Oh, maybe it's distributed. Wow, I am not spelling things correctly. Okay. Yeah, I think it's distributed. Yeah, because we have Q here. We can factor that out. Yeah. I mean, that looks about right. Okay. What do you think, Nstunky?
Yeah, looks solid.
Okay, cool. We completed that page, so probably next time we'll finish up with these problems, and we finished on time.
Beautiful.
Thank you, Nstunky, for your wisdom, knowledge, and also your company. I really appreciated it.
For sure.
Especially all those that are in Nstunky's chat. I also appreciate chatting with you guys as well. It was also fun engaging with you guys. But yeah, if anyone's new to both of our chats, like drop Nstunky a follow.
Welcome.
Drop Nstunky a follow, and if you're watching this on my stream, give me a follow on Twitch if you like math or physics, or you just need a little study stream to keep you guys engaged. If you're watching this on YouTube Shorts or YouTube Live, drop a sub. Much appreciated. Helps us continue on with the mathematical journeys that we're both on. Do you have a YouTube, Nstunky?
Coming soon, and this time that's probably actually true. So folks who have been following me this year, I have been doing this sort of on and off collab with Jonas Reigns.
Mm-hmm.
And Jonas has an incredible presence outside of Twitch, and so is offering to do a little bit of work for me to get the YouTube set up, which is going to be very nice.
that would be very nice. Okay. Yeah, that's cool. Yeah, take your time with it. Take your time with it. We can always make more content about math, no matter what. Yeah, so thank you guys for joining us today. I mean, are you going to still be streaming Nstunky, or you're going to finish up now?
Yeah, I am going to keep going for a little while longer. You're going off stream. Are you also headed AFK for a while?
Wait, ask that second part again.
Are you headed AFK for a while? You need to take care of real shit?
Yeah, I'm just going to go. I'm going to go, basically.
Yeah, for sure.
Yeah. But thanks for joining me today, guys. I don't know if I should just give you a raid and Nstunky, since our chats are the same.
Sure, might as well. I don't really know how this all goes, but I will stop talking for a little while so that you can say a proper goodbye to folks. But
okay.
Thank you.
Yeah. I'll just log off Discord. All right. See you later, Nstunky.
See ya.
Alright, guys. Basically, that was fun, being able to engage with Nstunky. And I will also give Nstunky another shout out. There we go. Yeah, there we go. So be sure to give Nstunky a follow, guys. He's really an awesome dude. But yeah, thanks for joining me today, guys. Like I said, all the links will be down in the description down below if you're watching us on YouTube. If you want to join us on our Discord community, you're more than welcome to do so. If you wish to engage in my gaming channel, my Uncle Fox channel, we're going to do a podcast tonight. So if you would like to engage with us there, you can engage with us. Not with Nstunky. I'm going to do a podcast with my good friend Rainier. We get to talk about more than just math. We get to talk about life in general, or whatever it is we would like to discuss. So thank you guys for joining me today, guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys in the next stream. So I'm just going to give Nstunky a proper raid for Twitch. And I will definitely catch you guys later. So take care, guys. Bye-bye.